Hello, welcome to Side A, Side B. We're going to be following up on a previous video and solve the Rubik's Cube with the Dive and Slide algorithm. The keyhole method brings up a really good question. And the question that we're going to be focusing on is, what's the least amount of applications of an algorithm or algorithms to solve 5 unsolved corners? Without further ado, let's get into it. I hope everyone's doing well. The first thing I want to go over is some algorithms bring us back to a starting point. Like if we continue with the sports theme names, if we refer back to the hop, skip, and the jump algorithm, that algorithm orients the third layer edges. But if I apply that algorithm over and over again, the hop, skip, and the jump, it's going to bring me back to the original spot where I started from. So if I start from the solved cube, it's going to bring me back to the solved cube. So like so. And voila, we're back to our original starting point, which was the solved cube. Now here's a result that I want to show you. I'm going to refer back to as we go further into the video. All right, so if we do that again, 1, 2, 3. So here's a result that I want you to pay attention to, because I'm going to refer back to it. Now pay attention, look closely on the position of these pieces. Okay, if you look at these pieces, this piece should go over here and this piece should go over here, and the same thing with these two pieces. Okay, and look at our U. We have 2 headlights. We have 2 orange headlights here and 2 red ones. Okay, that's going to be a result that I'm going to be referring back to. All right, so if we apply the hop, skip, and jump algorithm with this result, it's going to solve the cube. And voila, we're back to our original spot. Now, it goes the same way with the dive and slide algorithm. Now, this is going to take a while, but there's 2 results that I'm going to point out, and I'm going to refer back to them very shortly. Okay, this is going to take a while though. But if you notice, the dive and slide algorithm actually moves the edges and the corners. They manipulate the edges and the corners at the same time. But here we go. So if this is our starting point, if I use the dive and slide algorithm over and over again, it's going to bring me back to the original spot. All right, so let's do it. Now again, it's going to take a while. This algorithm manipulates the edges and corners. Almost there. So here's one result I want you to pay attention to, because I'm going to refer back to it. Here's a really typical result of the beginner method, where one corner is solved and 3 corners are in their correct spots but unsolved. Okay, so that's the result I'm going to refer back to. So if we just continue. All right, here's another result. Now this result is going to take us back to our original spot. But here's another result I want you to pay attention to. All right, so here's a typical result of a keel method, where we have 5 corners unsolved. But take a look. These 2 corners are actually in their correct spots but unsolved. These 3 corners are not in their correct spots, therefore they're not going to be solved. But take a look at the front. Not the front, our U. We have, I want you to pay attention to these 2 diagonals. These 2 diagonals, their colors match up. Okay, so that's this is a result I'm going to be referring back to. All right, and now take a look at this piece right here. See this blue piece? The blue, our bottom, the blue should be at our front. Okay, so the bottom, so with this result, the blue, the bottom, should be facing our front, on our front. Okay, so this result, if I, this result will bring us back. It's like I guess like a marker there, and it brings us back to our original spot. Okay. All right. So those are the. So I'm going to refer back to those 2 results. All right, very shortly. So let's get back to that result here. Okay. Okay, so here we have a typical result of the keel method using the dive and slide. We have we have 2 corners that are unsolved, but they're in their correct spots. And here's the result I'm referring back to, is this result right here. Then we have 3 corners that are unsolved, that they're not in their correct spots, so therefore they're going to be unsolved. Okay, so these 2 corners, now this result is very close to bringing us back to an original spot, which was the solved cube. All right, so actually these two corner pieces are in their correct spots, but they should be manipulated correctly. Okay? So, if you recall, our bottom should be facing towards the front, but our bottom is facing towards our left side. You see that? So this blue should be facing towards this direction, but but this piece is in its correct spot, and same with this piece. This piece is in its correct spot, but it's facing, this color should be facing upwards. So it's diagonal. So these two pieces that are diagonal, their colors match up. You see that? But it's going to take a while. But we can solve this cube by doing a couple moves and using the Dive Slide algorithm. All right. Almost there. Okay, here's the result that we're looking for. Now, here's three corner pieces that they're in their correct spots, but they're unsolved. Now, I'm going to refer back to that first result I pointed out to you was a typical beginner result where we have one corner that's solved and three corners that are unsolved. The three pieces are in their correct spots, but they're unsolved. So with a couple moves, we can make that result. Okay, and by turning our front, we basically have the same result of the first result I pointed out. Now if we apply the dive and slide, it's going to take a while, but it gets there. They eventually meet up. And voila, there we go. Now, we just retrace those two moves, and one move gets automatically retraced back. So we just have to retrace the first move. Okay, and voila. The Rubik's Cube is solved by using the dive and slide algorithm, but it takes a while. Okay, so that's why we want to refer back to the question. The original question was, what's the least amount of applications of an algorithm or algorithms to solve 5 unsolved corners? So let's try and answer that question. Let's go back to that original result, that we just did, and try and answer that question. Okay. Now we're back to original spot again. All right, remember what I said, that these two pieces are in their correct spots, but they need to be manipulated so the colors are facing in the right direction. So this blue should be facing in this direction, and this red should be facing in this direction. So these two diagonal pieces, the colors are matched up. Okay, but we can use our skills from a previous video of using the belly flop algorithm. Okay, so I'm going to use two applications of the belly flop algorithm, which is very similar to what I discussed in a previous video, and I'll let you discover on your own on how it's connected to a previous discussion about the belly flop algorithms. All right, so I'm going to use two applications of the belly flop algorithm to manipulate these two pieces so the corners, so the colors are facing in the correct direction. All right, so I'm going to use the right-handed belly flop. It's the right-handed, and then I move the back like so, and then I use the left-handed belly flop, and then I retrace the back again. All right, so now that those two applications of the belly flop algorithm manipulated these pieces so the colors are facing where they should be. All right, so the blue is facing in its correct direction, and now the red is facing in its correct direction. And now we apply the Dive Slide algorithm. Now this is the result that's going to take us to a home run. All right, so let's do it. And voila. It's like we just did a time jump. It's like we stole. It's like we stole all the bases somehow in a space-time continuum or something like that, and we just kind of jumped time to that result, which brings us home. Beautiful. All right, now I'm going to answer that question again. I'm going to do another result, and it's going to give you something to think about again. So here's a result I want to show you. All right, so here's a result. Here's a typical result of the Keel method. 5 corners are unsolved. Now we can either use 2 applications of the belly flop algorithm to solve this, or we can use 1 application of the belly flop algorithm and then in 1 application or 3 applications of the hop, skip, and the jump. And I'm going to show you, and I'm going to refer back to that first result I showed you. Okay? All right, so we do a few moves, and then we do the left-handed belly flop, right? We retrace those moves, and here again. Here's the result of here's the first result I pointed out to you. Okay? Now, if you recall the position of the pieces, this piece should go here, this piece should go there, and same with these two pieces, okay? And take a look at our U. We have our 2 orange headlights, and we have our 2 red headlights. And now, and this is the result I'm referring back to, okay? So if we apply the hop, skip, and the jump algorithm, it's going to solve the cube, all right? So let's do it. And voila. Fabulous. There's 2 examples of answering that question. What's the least amount of applications of an algorithm or algorithms to solve 5 unsolved corners? And that completes the video series, the Keel method. If something occurs to me again, I'll post another video. Let me just say it's been an absolute pleasure to bring you this series. We want to thank you for coming in, checking out the videos. We also want to give a shout out and thank you to the inventor of the Rubik's Cube, Erno Rubik. I hope I pronounced the name right. I think what the Keel method does is it leaves an open question for us to answer. There's multiple results of 5 unsolved corners, which means there's multiple challenges to solve. I think learning the Daisy method along with the beginner method, and then combine that with the Keel method, those 2 methods can help any individual to master the cube. Afterwards, literally spin anyone in any direction they want to go. And again, with so many variations to solving the cube, you really hold the key.